Okay, thank you very much. Well, my name is Juan Pablo. I am part of Canonical Data Center Field Engineering team. Canonical is the company behind Ubuntu. We're the ones taking care of it being secure and making it widely accessible for many, many use cases. The team that I work for, we are the ones that are in charge of designing and delivering many infrastructure solutions. And that's going to be the starting point for the use case that I'm going to share. That's all. Something. Oops. So as part of the role of being a field engineer, we have, I'll say, too many solutions to take care and too many documentation to be able to access and consume effectively to do well or work. So that's how we figure out that implementing an internal RAG use case that allow us to effectively consume that information, be more efficient in the way we troubleshoot in our day-to-day works, the way we perform pre-sales, or we deliver design sessions for any of our products, was very beneficial. So behind that motivation, we know that retrieval search is the cornerstone for enterprise GenAI applications. As part of our portfolio, OpenSearch, it's one of the charm applications we offer for our customers. And we decided to start exploring how we can use OpenSearch for this internal use case. So RAG in its most basic scenario, it's this. Retrieving and then augmenting the information that you have. So the first part of the presentation, it's a small refresh on what you can build on top of OpenSearch. OpenSearch, for me, it was surprising that it's a one-stop shop solution for RAG, since it being the vector database, but when you explore the ML Commons features on top of it, you will figure out that it's many things that you can do in a single application for the entire solution. So a part of its vector database capabilities, OpenSearch through the ML Commons plugins offer many useful toolsets for a RAG workflow, from the inferring of sentence transformer models to basically be able to build your ingestion pipeline inside OpenSearch itself, connectors to external large language models, so we can consume LLMs from public APIs or infer on-prem through solutions like KeyServe or any other inference engine that we run on-premise. This will take relevance later. Even allows you to build memory indexes, so you can store the conversation that you are building with your conversational application, with your chatbot or whatever type of LLM-based application you are developing, and apply some guard rates filters for, let's say, keeping the LLM in the boundaries that you expect to act and respond. So from the perspective of the tools, the ML Commons plugins, this is how the most basic RAG workflow looks in OpenSearch. So you can build a model that you can use for creating your sentence embeddings. It is going to be inferring your CPU, and OpenSearch is going to take care of it. You can then build an KNN index that you can, let's say, configure to use that model as its default ingestion pipeline. So every time you publish a document, it's going to do the transformations to the sentence embeddings and store the sentence embeddings in the index, as long as the text and the metadata you want to add to that object. Then we will have the model connectors that will allow us to interact with external LLM models, as I already stated, and build a complete workload when from a single index you can search against the index, and the result of that search, it's going to be the top results plus the augmentation that you're going to get from the LLM. Here, the only thing that is happening outside OpenSearch may be the interaction with an external infer LLM, but the rest is built inside OpenSearch. And for me, that was wonderful. It's a one-stop shop for RAG. So At the end, you can build queries that will look similar to this. You may want or not want to get the sentence embeddings out of your search result. It's going to be a neural query where you are going to interact with an external model. So you'll have different models, different components on that flow, but again, everything is happening against the OpenSearch endpoint. So in case you're curious, here you'll find some notebooks on how to implement the most basic version of it that I already showed. And then there is the notebooks that you'll find there can work against any OpenSearch cluster, but in case you're curious and you want to try it on Charm OpenSearch, there are going to be some links and useful information on how to get how to deploy Charm OpenSearch and get it to work. Okay, so moving forward to the next part, let's say that on each step of the evolution of LLMs and how their context window grows, RAG has been declared dead many times. On multiple milestones of growing the context window of LLMs, it starts to be tempting, the idea of giving all your information to the LLM and let it figure it out. It's tempting because there's not more chunk processing, there is not more relevance ranking, and complexities that comes with tuning or setting a enterprise-grade RAG workflow. But it is very naive when you think it from a security perspective. It's going to be very, let's say, insecure if you basically are exposing all your confidential information against a single model, and if you have multiple users interacting with that model, it's going to be impossible to control what the model will be answering for you, if that information is for you or not. So the question was, what about security? So we have the tools, we have different alternatives. And the question that we had internally, it's, for example, if you're trying to provide support assistance to a customer, and one customer has confidential information about its infrastructure, you don't want that information to be available to other customers that it's asking regarding a solution, a knowledge-based case, a support case that it's trying to fix. So most GenAI implementations prioritize answer precision over data governance, which it's creating significant confidentiality vulnerabilities in the RAG solutions that enterprises are implementing. And this is very relevant, especially for organizations where the access to information is subject to very strict access controls. So that's why RAG is not dead. RAG acts very well as a gatekeeper for conversational applications. It allows you to enforce access controls to the information that the LLM is going to be able to answer your argument, given the question that you are providing. And as the title says, it's going to act as the gatekeeper for the access control of your environment. So OpenSearch has some built-in security features that can help you with that. The document-level security through one of the different mechanisms it exists, parameter substitution being the first one, or attribute-based security, for example. But we decided to try a different approach in our use case. We decided to explore how we can use the CNN post-filtering in order to filter the content that the final user is going to receive. So there are different alternatives of filtering in OpenSearch. They all have their, let's say, performance impact when you're performing your CNN queries. So let's say that one of the approach could be the search, the post-filter parameter. This is going to happen outside the query. Basically, you're going to get less answers than K because the filter is going to be strict and it's going to happen after you perform the approximate search. And the flow is the same. So you will get your answers. The LM is going to only receive the filter context as a context message for the prompt. We have the efficient KNN filter. This one is going to happen inside the search. It's going to be, let's say, implementation based on the different methods that you will use. If it's phase is going to be one. Lucene implements another one. And the final goal is to, in the way you introduce the less latency possible, be able to filter the results or the context that the LLM is going to receive based on some mechanism. In this case, I am passing a list of source object e-tags that I will allow for that particular query to use for the augmentation phase. So the idea was to build something based purely of open source solutions, and then we decided to explore a little bit an external fine-grained authorization tool. This is OpenFGA. It's part of the Cloud Native Foundation ecosystem, and it allows me to build a performance, low latency system to assert against authorizations and figure out a way to create a store of permissions based on relation-based access controls. It's also possible to deploy it with Juju. It's Charm too, so there's a couple of comments on how to get it up and running. And it works a little bit like this. So we will have a model. The model defines the different, let's say, primitives of or basic objects, starting by the user, then the document, some attributes that you will apply to that object, and then you will have a store that will create that relationship based of tuple and condition. So a user will be able to, will have a relation to the object, and based on that, you then can perform assertions or a list object, for example, a query where you'll get, based on the store that you created, what are the objects that the user has access to. So how it fits in the flow, basically what we will be doing, it's creating that as part of the business logic on the authorization side. We will, in the middle, have a router that will allow us to extract that information and create the query. So we can provide the list of objects we expect the KNN to filter and retrieve as part of the context for the augmentation. So finally, what we were trying to do is to do a POC of a RAG solution based only on open source solutions. This is basically what we ended doing. We use Ceph for the object storage on top of OpenStack. From there, we interact through a RAG router to do the ingestion to the vector database that, of course, it's OpenSearch. We use Kafka for, let's say, many roles in the solution, one of them being the buckets notification. Every time an object is created, it triggers an action on the RAG router that it's going to consume and ingest the document, create the chunks, of course, and use the ingestion pipeline of the index. And then we have OpenFGA that the RAG router, every time we get a query via Mattermost or Matrix being the front end of the conversational solution, it's gonna create the query, well, do the assertions, list the objects that the user that is doing the query can access, and finally create the search body of the petition that it's gonna ask OpenSearch to answer and augment. And that's kind of the core of the solution. Then, as I mentioned, we are doing everything on-prem, so we use Keyser for as inference service for BLM, and we were testing these two open source LLMs that were very interesting to providing the first results. And that's kind of what I had to share. I don't know if there are any questions, something you'd like to talk about. If not, thank you very much.
So basically this is not part of OpenSearch yet, is that right?
No, it is not. It's an application that integrates OpenSearch with other open source components for building this final solution. Correct.
And then matching that via filters to OpenSearch. But my question is whether the key tags are like document level tags, like for example, you have access to 1 million documents, it will be like 1 million entries.
Yeah, so the e-tags are actually coming from the data store, the object store. So in this case, Ceph, Browse Gateway, will give me the e-tag of the object once the object is uploaded in a bucket. And then we're using that as one of the attributes of the index. So we can then map the object, the permissions, and then do the filtering effectively.
But if you have access to like a large amount of objects, that will be an issue. Like when you pass this filter, it will be too long.
Yeah, it can be. The scalability of it, once you are doing the filtering for it, that's why we also are exploring the idea of having different indexes for different contexts. So when you have the final filter, maybe you don't have that long list of e-tags, but yeah, the scalability is still to be reviewed.